बिस्मिल्लाहिर्रहमानिर्रहीम सल्लल्लाहु अलैहि व आलिहि वसल्लम अल्लाहुम्मा रब्बि ज़िदनी इल्मा अस्सलातु वस्सलामु अलैका या सय्यदी या रहमतल लिल आलमीन आमीन अल्हम्दुलिल्लाहि रब्बिल आलमीन. In this video I will be solving the P3 Feb March 2026 paper. Please stay focused and watch the lecture till the end. Simply watching the final solutions will not be enough to fully understand this paper. So make sure you follow the complete explanation carefully. This paper contains a lot of algebra along with some challenging questions. Therefore, watch the solution to every question very carefully so that you can fully understand the methods and concepts involved. Be kind to others. Let's begin. Question 1. This question is of index equation and we use substitution method to solve these types of questions. That's the hint, use substitution. And for substitution we have to separate 2 power x. We need 2 power x for the substitution. So first split the powers and get 2 power x. So for 2 power x plus 2 will become 2 power 2 times 2 power x. This is according to rules of indices. Minus 5 is copied. 2 power 2 minus x. So 2 power 2 is here. Because of minus x, write 2 power positive x in denominator. And copy 3. Now simplify this. This is 4. 4 times 4 makes 16. So 16 times 2 power x. Minus 4 5s are 20 divided by 2 power x. Now use substitution. Let 2 power x be v. So 16 v 20 upon v is equal to 3. Take the LCM and simplify this expression, this equation. So finally we have 16v square minus 3v minus 20 is equal to 0. Factors are not possible. So use quadratic formula. v 3 plus minus 9, 3 square is 9, minus 4 times 16 times minus 20. You have to show this step. And in denominator we have 16 times 2, which makes 32. Now replace v by 2 power x and write the simplified form of this, which is 1289 under root divided by 32. So we have two possibilities. One is 2 power x 3 plus 1289 divided by 32, and the other one is 2 power x 3 minus 1289 divided by 32. Now taking ln on both sides. ln 3 plus 1289 under root divided by 32. This entire thing is positive, so this result will exist. Here this will become negative, so ln will be invalid, but I am showing the working. ln 2x ln 3 minus 1289 divided by 32. Alright, so from this equation we are getting x 0.282 in 3 significant numbers, or up to 3 significant figures. From here we are getting ln 2 power x ln minus 1.0282. So this is invalid. ln does not exist for any negative number or 0. So that's the final answer up to 3SF. Please check the solution. I'm sorry. Next question. This question is of complex numbers, Argand diagram. A similar question of this type, the first part, came in 2024. Okay, so we have to understand this with this argument. Since argument is given, so read this with the given argument. So this means, in fact, this means second quadrant, 90 and 180. So this quadrant. So this should be an arc of radius 9 in second quadrant. Try to understand this. Don't draw a complete circle. We need an arc. In fact, quadrant. See, this angle is pi by 2 is between pi to pi by 2 or pi by 2 to pi. This is here. On the Argand diagram, sketch the locus of the points representing z. Done. This is z, locus of z. Now the next part. On this same diagram, sketch the locus of the points representing z steric plus 3, conjugate of z plus 3. Conjugate, let's break this into z steric and 3. So plus 3 means 3 units to the right, translation of 3 units right. Okay? And z steric means the reflection in real axis. Steric is the reflection in real axis. So this means reflection in the real axis. Reflection of what? Reflection of z in the real axis. Okay? I wrote these things just for your conceptual clarity. Now first go for z steric. So z steric means reflection of this in the real axis. So this would be like this. All right. So this is reflected here. Now we have to shift. We have done this part. We have done the steric part, conjugate part. This is the conjugate. This is the conjugate. Now we have to translate this to 3 units right. So when we translate this curve, so this point will come here, -6, and 0 will come here, 3. So this point will be here. This 0 minus 9i will come here, 3. Let me write the points here. So 3 minus 9i okay, and this 0 minus 9, sorry, minus 9 and 0i will become minus 6 and 0. This will come here. Now let me sketch the resultant graph. Let me show this. If I shift this to 3 units right, see, I'll get this result. Okay, I'm copying this. Now see. This point is three minus 9i, okay, and this is minus 6 plus 0i. This is the final sketch. You can either erase this part or show it as a broken curve. So this is part A, this is part B. This is Z static, plus 3. Please check this solution again. You have option, you can either erase this or just show as I did, as a broken curve. Next question 3. See, we have product of sine and sine. This is sine 2x. We need to use double angle formula to simplify this. Sine 2x is 2 sine x cos x, and then we will be able to integrate this. So pi by 4 limits. Make sure your calculator must be in radian mode throughout the P3, except vectors, questions and trigonometry domain in degrees. Trigonometry questions where domain is in degrees. For the rest of the paper, keep your calculator in radian mode. 3 sine x. Now I'm simplifying sine 2x as 2 sine x cos x, okay? Pi by 4, 3 pi by 3. So we have 6 sine x square whole square and cos x. Now this is the structure of basic formula 1. We have product of like functions. So use basic formula 1. Why? Because we have a structure of, we have product of like functions, trigonometric. You can bring 6 outside the integral to make integration simple. Now, according to basic formula, this is the function and its differential is here. If you differentiate sine x mentally, you will get cos x. So we have complete differential. Nothing is missing in this differential. So according to basic formula 1, copy this. Sine x, add 1 in power, so 2 plus 1 makes 3, divided by the resultant power. This is basic formula 1. You can watch my lectures on basic formula 1. So 2, now apply the limits, sine pi by 3 whole cube minus sine pi by 4 whole cube, right? Sine pi by 3 is under root 3 upon 2. Sine pi by 4 is 1 upon root 2. Under root 3 cube is 3 root 3 and 2 cube is 8. You can first rationalize this under root 2 upon 2 and then cube it. 3 root 3 upon 8. Okay, so we have 2 root 2 upon 8 here. Under root 2 cube will become 2 root 2. Now we can take 8 common, so we have 2 upon 8 which is 1 upon 4. 3 root 3 minus 2 root 2. We have to give our answer in this form. So 1 upon 4, when we multiply this with the bracket, we will get 3 upon 4 root 3 minus 1 upon 2 root 2. Now compare this with the given expression. Now the given expression is p root 3 q root 2. P root 3 q root 2. So when we will compare this with our answer, we will get the values of p and q. So p is 3 upon 4 and q is minus half, and these are rational numbers, fractional forms. The fractions of integer means rational number. So we have got the answers, we have got the values of p and q. Please check this solution again. Your algebra must be very good for P3, because P3 involves a lot of algebra. So you should practice as many papers as possible. Next question. The coefficient of x cube in the expansion of, let me show you MF19, because we need MF19. It's here. See, this is very important. I'm sorry. This is the first term, this is the second term, this is the third term, this is the fourth term. So, in third term we have a square here, fourth term cube here. And this is the structure. This is the formula for the fourth term. N minus 1, n minus 2, 3 factorial x cube. This is the formula for the third term. Okay, it says the coefficient of x cube. So we get coefficient of x cube in the fourth term. See, x cube. So we need fourth term. The coefficient of x cube in this expansion is 1. So I need coefficient of x cube. So let me write the formula first. It's T4 n minus 1 n minus 2 divided by 3 factorial and second term to the power 3. Check this again in MF19. I just copied this. Alright, So it says the coefficient of x cube. That means we have to use this formula for coefficient of x cube. So T4, I'm substituting values, okay? Second term is, let me write b here so that you would easily understand this. Otherwise, you will be confused with x. This is the second term. So second term is, here in this expansion, the second term is minus ax. Take the second term with sign. This is the second term. Minus ax, okay? And what is n? N is 2 upon 5. Now substitute these two very carefully in the formula of Tn, T4. So n is 2 upon 5. N minus 1, 2 upon 5 minus 1 makes minus 3 upon 5. Minus 3 upon 5 minus 2 makes, in fact, n minus 2. This minus 1, this one. See, n minus 1, n minus 2. So just minus 1 from this. So minus 3 upon 5 minus 1 will give you minus 8 upon 5. You have option. You can also do n minus 2. You will get the same thing. 3 factorial means 6. And second term is minus ax to the power 3. Now get its simplified form. So 2 upon 5. See, negative will be positive and this negative will remain. So negative, this negative is here. Now see, 6 times makes 48. So minus 48 divided by 5, 5, 5 and 6. So 125 times 6. And here we have a cube. Okay, x cube. This is the fourth term. Now we need just coefficient. You can draw the margin. It's perfectly fine and it's allowed in Cambridge. Alright, so coefficient is this. This is the coefficient. And this is equal to 1. It says the coefficient of x cube is 1. So now equate this minus 48 upon, okay, we can simplify. Minus 48 upon 6 is minus 8 upon 125. This and this will become minus 8. After cancellation, a cube is copied and 1. This is given. This is here. So finally we have got a. It's, let me show the working. A cube minus 125 upon 8. Now take the cube root on both sides. So a is minus 5 upon 2. That's the value of a. See the importance of MF19. So you must be used to with MF19. Now find the coefficient of x power 4 in the expansion of 2x plus 1. We have coefficient of x cube. It's 1. Now we need coefficient of x power 4. Let me assume this as D or C. Let's suppose the coefficient of x power 4 is C. In this expansion, I need two coefficients from this expansion. The coefficient of x cube, which is already given, and coefficient of x power 4. Why? Because when I will multiply 2x with this, I will get x power 4. See the logic. Why I need this extra term? Because when I will multiply this with this, I will get x power 4, right? In fact, I will get 2x power 4. And when I will multiply this 1 with this, I will get x power 4. And I will get cx power 4. And the coefficient is 2 plus c. Now first I need c. So for c, please see and please understand. For x cube, I found t4. So for x power 4, I must find t power 5. I mean the fifth term, t5. So for x power 4, find t5. So t5, n, which is minus 2 upon 5, n is 2 upon 5 in fact. So 2 upon 5, n minus 1, minus 3 upon 5, n minus 2, minus 8 upon 5, n minus 3, minus 13 upon 5. Please try to understand this. For cube, we have n minus 1, n minus 2. What if we had 4 here? Then we had n minus 1, n minus 2, n minus 3. So this is n minus 1, n minus 2, n minus 3, and divided by 4 factorial. And here write the second term with power 4. And the second term is ax, and we have the value of a. It's 5 upon 2. Okay, I'm writing ax. I'm not writing because of negative sign. Maybe you will get confused. So this is the fifth term, the coefficient of x power 4. Now get its simplified form. When you will simplify this, you will get minus 13 upon 8. If you substitute the value of a here, it will be easy to evaluate. 5 upon 2. See, we had minus a here and a is minus, so it will be 5 upon 2. So the simplified form of this is minus 13 upon 8 x power 4. So this is c. This c. Therefore 2 plus c. So 2 minus 13 upon 8 will give you coefficient of x power 4, which is 3 upon 8. Okay, I'm giving you 1 minute. Please check the solution of this question. Very small space is here and you have to utilize it very carefully. For this solution, I use MF19, this formula, this is T4. For T4, we have cube here. For T5, we must have x power 4 here and 4 terms here. See, for cube, we have 3 terms, 1, 2, 3. For 5, we must have 4 terms, n minus 1, n minus 2, n minus 3, 4 factorial, second term to the power 4. Now the last part of this question. State the set of values of x for which the expansion in 4b is valid. So take this expansion, this one. For this part we need power expansions. So 1 minus ax. So its power 2 upon 5. In fact, take both the expansions. If we have product, then take both the expansions. 1 plus 2x. Okay. Now use this concept. Binomial expansions, when first term is 1 and this expansion is valid for these values. Modulus x less than 1. Now use this thing. So if we have product, always take both the expansions and use this. Modulus x less than 1. Now substitute the second term. Second term is minus ax, and we have got the value of a. So substitute a into this expansion. So 1 plus 5 upon 2 x whole power 2 upon 5. Okay. Now you need to replace this x by this second term. This is the way to find set of values. Always replace this x by the second term of the expansion. So we have 5 upon 2x less than 1. Now simplify this for modulus x. So it's 2 upon 5. Okay. Now from here, substitute the second term. It's 2. Okay. 2x, sorry. Now get x, modulus x, it's half. Now from both, we have two values. Now from both, take the smaller one. Why? Because the smaller one is the solution. See, the answer is a smaller value. And here is the logic. Why smaller value is the answer? Because if we sketch these, so this will go here and this will go here. So that's the solution. This is 0.5 and this is 0.4. So that's the right answer. If we sketch in case of modulus, then you remember modulus, when you simplify modulus, you'll get like this, minus 2 upon 5, 2 upon 5. So this and this. See, this is the final answer. So modulus x less than 2 upon 5 is the final answer. This is just for your conceptual clarity. So whenever we have product, get the values of modulus x from both the expansions like this, and take the smaller one from the both. That's the final answer. Please see the solution. Next question is of complex numbers. It is given that z is 3 plus lambda I divided by lambda plus 2i, where lambda is a real constant. Find the value of lambda for which argument z is pi by 4. Argument z pi by 4 means z is in first quadrant. Here. Okay. Since z is in fractional form, so we have to rationalize this. If we have I in denominator, then always rationalize the complex number. Because for argument and modulus, the complex number should be of this form, a plus bi. We have to eliminate this I from denominator, and for that we need to rationalize it. So lambda minus 2i lambda minus 2i. Now do the multiplication very carefully. See, 3 lambda minus 6i. Then lambda square I plus 2 lambda. In denominator we have a square plus b square. So lambda square minus 2i square. You can directly solve this as well. This is lambda square plus 4. But I'm just showing all these steps for your conceptual clarity. Lambda square plus 4 because I square is minus 1. In numerator we have 5 lambda because this will become 5 lambda. Now take I common from these two, so we have lambda square minus 6i. Now break the LCM and get this form, a plus bi, the standard form of complex number. Now this is the real part and this is the imaginary part. And both must be positive, this and this, because of argument. Argument is in first quadrant. So both real and imaginary part should be positive. Now get the argument. Let me make some space here. In this paper, the space is very little. Very less space is given. It's very hard to fix the solution in this given space. Alright. Now we need argument z. Argument z, the formula is tan inverse imaginary component divided by real component. See, when you will divide this with this, the denominators will be cancelled. So we have lambda square minus 6 divided by 5 lambda. So always do this in this way. If we have common denominators, just ignore those because they are cancelled. This is 1, I'm so sorry, this is pi by 4, argument z, this is given, it's here, argument z is pi by 4, tan inverse lambda square minus 6 divided by 5 lambda. Okay, we have to make a margin, draw a margin. Alright, so bring this tan inverse here. So when we will bring tan inverse on right side, we will get tan pi by 4. Left side, in fact, this is the left side, sorry. And lambda square minus 6 upon 5 lambda is copied. Okay, tan pi by 4 is 1, so lambda square minus 6 divided by 5 lambda. Get the quadratic equation. It's lambda square minus 5 lambda minus 6. Break the middle term. So we have lambda square 6 lambda plus lambda minus 6. We are getting two values. Lambda is 6 or lambda is minus 1. Minus 1 is rejected. Why? Because when we will substitute minus 1 here, this real part will be negative, and complex numbers argument won't be pi by 4 then. So reject this part because complex number is in first quadrant because of the given argument. This is the easiest way to explain this. So the value of lambda is 6. So make sure you decide the correct value according to the given argument. Please check the solution. When lambda has this value 6, find the exact value of modulus. Now substitute lambda 6 over here. Therefore the complex number z is 6 5s are 30. I'm substituting here. Okay. Just for your reference. 30 lambda square is 36 plus 4 40. Lambda square 6 square 36 minus 6 30 divided by 40. So we have got z 3 upon 4 3 upon 4i. Okay. Now get its modulus. Just square the real component and imaginary component. 3 upon 4, 3 upon 4 square square. This will give you 9 upon 16, 9 upon 16, which is 18 upon 16. So 18 means 9 to the 18, so 3 root 2 divided by 4. That's the exact value of modulus z. Okay, 1 minute break, then I will continue this. You can just check the solution. I'm taking 1 minute break. For the relaxation of my eyes, I'm taking 1 minute break. For P3, you should practice as many past papers as possible, and you must be very good at concepts first and then practice. If you lack in concepts, then first work on your concepts. I mean, concepts are foundation. If concepts are good, then practice will benefit you or help you. In P3, both things are equally important, concepts and practice. A lot of algebra is involved and time management. If you lack in practice, then you won't be able to complete the paper in the time or on the time. And must avoid careless mistakes. When you practice, you have to avoid careless mistakes. You can't avoid careless mistakes in exam unless you avoid careless mistakes during practice. Okay, next question. Question 6 of polynomial. The polynomial is denoted by px. It is given that this is a factor, find the values of a and b. Now see, there are two unknown constants. Since there are two unknown constants, then always use comparing the coefficient method. That's the hint. As two unknown constants, then use comparing the coefficient method. Okay, let's solve this. 2x power 4 ax cube 4x square bx minus 3. Copy the given quadratic factor, which is x square plus x plus 1. Now suppose a quadratic factor, because we have power 4, so we must have another quadratic factor here. So it should be px square plus qx plus r. Use different constants, don't use ab. Even a capital A can confuse you. You can use ABC, but it's better to use different constants. Now multiply the right side very carefully. So when we multiply this x square with this whole, we will get px power 4, then qx cube, then rx square. Similarly, when we multiply x with this whole thing, we will get px cube qx square plus rx. Now when we multiply 1 with this, we just need to copy the entire factor px square qx plus r. Now comparing the coefficients of like powers of x on both sides. At first I am comparing coefficients of power 4 on both sides. So the coefficient is 2 here and here p. Therefore p is 2. Always compare the highest powers coefficient at first and then constant. This will make calculations simple and fast. Now I am comparing constant terms, or coefficient of x power 0, you can say. So minus 3 is equal to r. So we have got r. We compared constants on both sides, this with this, the terms independent of x. Now I am comparing coefficient of x power 2, x square. You have option, you can compare cube at first. So coefficient of x square, this is 4, here 4, and here we have p r q. Okay, so 4 is equal to r plus q plus p, and we have r and p. So minus 3 plus q plus 2. So we have got q. Therefore q is 5. Now I am comparing coefficient of x cube. On both sides. I'm sorry. Coefficient of x cube. So it's a on left side, on right side it's q p, that's it, q plus p. We have q, we have p, Q is 5, P is 2, so A is 7. So we have got A. It's 7. Now comparing the coefficients of x power 1 on both sides. So x power 1 on left side we have B, on right side we have R Q. So R plus Q. So R is -3 whereas Q is 5. Therefore B is 2. Hence the values of A and B are 7 and 5, 7 and 2 respectively. See, a lot of algebra is required. Also do it very carefully. Great concentration is required to avoid careless mistakes. Hence show that x plus 3 is a factor of p of x. This is very simple. We just need to first copy the polynomial. It's 2x power 4. Then a, which is 7, x cube, 4x square, b is 2, minus 3. We just need to substitute minus 3. So p minus 3, 2 minus 3 power 4, 7 minus 3 cube, 4 minus 3 square, 2 minus 3 minus 3. So use calculator. So 2 times 3 power 4, square is, negative is cancelled. This is 162. 7 times 27, this is negative because of odd power. 7 times 27, this is 189. 9 times 4, 36, minus 6, minus 3. Alright, so 162 minus 189 plus 36 minus 9 is equal to 0. Hence shown that x plus 3 is a factor of p of x. Please check the solution. Next question, iteration. By sketching a suitable pair of graphs, show that the equation ln x is equal to cosec half x has exactly one solution in the domain 0 to pi. Try to understand the sketch of sin x first. This is sin x. It completes at 2 pi. What if it's sin x upon 2? Then this will be 4 pi. This is 2 pi. And this is pi by 2. Sorry, pi. So we have to sketch cosec till this point, 0 to pi. To sketch cosec, first make a rough sketch of sine. This will help you to sketch cosec easily. Label the axis. This is 1. This is sin x till pi. Okay. Sine will help you to sketch cosec easily. See, sine 0 is 0, so cosec 0 is infinite. So this is cosec. All right. Here is the cosec x, right? Cosec is vertical, parallel to y-axis here. This is 0, this is 1. Now you can erase sin x, or you can show it as a broken curve, but it's better to erase it. This basically helps us to sketch cosec easily. Now we have to sketch, okay, show this as a broken line. Now we have to sketch ln x. Ln x is very simple. This is ln x. It cuts at 1, 0 on x-axis. Not helping me. Okay, finally done. Oof. This is ln x from 0 to pi. See, pi is 3.142. This is 1. Make sure you must show this intercept. This is also 1. You have to show this as well. You should label these graphs as well. This is y is equal to cosec x upon 2. This is y is equal to ln x, right? And here is the solution, one intersection. So we had to show this. We had to show that this graph has just one solution in this interval. This is the intersection. All right. Next, verify by calculation that this root lies between 2.6 and 2.9. For that, we need to rearrange this equation and equate to 0. So it's ln x cosec x upon 2. So we can write this as ln x 1 upon sine x upon 2. Okay. Now bring this on left side and equate this to 0. So ln x minus 1 upon sine. You can arrange the equation in any way. Sine, I can write this as 0.5x is equal to 0. Now suppose this as f of x. Because of lack of space, I'm writing this here. Now suppose this equation as f of x ln x 1 upon sine 0.5x. Okay, now substitute these values in radian mode. Make sure your calculator must be in radian mode. 2.6, this will give you 0.0823 negative answer, and then get 2.9. The result of 2.9 is 0.0574 greater than 0. As sign changes, from negative to positive, hence shown. Done. Next part, iteration. Use the iterative formula. So sorry. Okay, before using this formula, alright, first write this formula: xn plus 1 e cosec half x. Cosec, we can write cosec as 1 upon sine 0.5x n, because in calculator we don't have cosec, so we have to convert cosec in the form of sine. So this is e power cosec 0.5x. Now write this as e power 1 upon sine 0.5x. Now get the x1. How to get x1? And remember, we have to show each iteration up to 5 decimal and final answer up to 3 significant. Okay, x1 is the average of these two values. Take the average of these two to get x1. 2.6 plus 2.9. If x1 is not given, then take the average. So it's 2.75. Now for x2, put the formula this in your calculator and then plug in 2.75. When you will substitute 2.75, you will get 2.77175. 5 decimal places, okay? Make sure you round the decimal. This 6 to this should be rounded off. Now correct to 5 decimal places. x3 is 2. For x3, substitute this in your calculator. 2.76584. x4, we have to continue this process until we get a repeated number. 76741. x5, 2.76699. x6, next value 2.76710. Now it's getting close. 2.76707. x8, 2.76708. x9, same answer. The number has repeated. We have got the repeated answer. Therefore, take the 3 dp value. Hence, x is 2.767. So repeat the process until you get your repeated number. or a repeated pair. Here we got repeated number. Okay, 20 seconds break, 20 rule. It's hard to make a 2 hours video. You must use 20 rule. I had an eye injury, so please pray for me that I will get better soon. Thank you. Question 8. Differential equation. See, differential equation, so we have to first do variable separable. Let me first copy this. In variable separable, we shift dx on other side, I mean this operator on this side, and we keep this on left side. Since we have dy here, so we have to bring y plus 5 here, and we have to shift e3x here. So we have to shift e3x here, dx here, and we have to bring this here. This is the way we do variable separable. So y upon y plus 5, okay, and write dy as it is, x upon e3x dx. This is the way to do variable separable. Now taking sign of integral on both sides, this is an important question. Bring 3x in numerator, it will become e minus 3x dx. Now this is product of different functions, so we have to use by parts here. This is an improper fraction, so we have to split this fraction by using long division method. There is a shortcut to split this, but I never use shortcut. I always use long division to avoid careless mistakes. So first use long division to split this fraction. This fraction is improper, so split it by using long division method. So y plus 5, make sure you write both in descending order, the polynomial and the divisor, the dividend and divisor both. Now divide this y by this y, we will get 1. Now multiply this 1 with this whole, so we will get y plus 5. Now opposite the signs or change the signs, we will get minus 5. This is quotient, this is remainder. Now the rule is dividend. Let me check the rule in MF19 so that I will not copy it. If it's here, I think it's here. No, it's not available, I think. Okay, let me write the rule. Dividend, divisor. This is just for your conceptual clarity. In exam, you don't need to write this rule. Quotient plus remainder divided by divisor. Okay, this is the way we split improper fractions. dividend is y, divisor is y plus 5, quotient is 1, remainder is -5, and this is y plus 5. So we have split the fraction, and this is the way to split improper fractions. Alright, now copy this. And replace this fraction by this new fraction, 1 minus 5 upon y plus 5. Okay. Here we have to use by parts. So just copy this. Let me first integrate this and then I will use by parts on right side. So when we will integrate, okay, I forgot to write dy here. Always write the operator. It's compulsory. The operator should be with sign of integral. The sign of integral, the operator, and the function. This is the proper way. Alright, so when we integrate one, we'll get y. And when we will integrate this is basic formula 2. Copy 5, and y plus 5 will become ln modulus y plus 5. The differential of y plus 5 is 1. So if you want, you can write it here. Otherwise you may leave it. We write the differential here of this function. Over here we will use by parts. Now call it equation 1. Now consider the integral x e minus 3x dx. We have product of algebraic and exponential. So according to Liet, algebraic comes before exponential. So algebraic is u. So this function is u, and this function with dx is du. So let u be x and dv be e minus 3x. So du upon dx is 1. So du is dx. Box u, box du, and integrate this. So v is, in exponential we copy exponential and we divide it with the differential of its power. So this is v. Right? Box it as well. Now by parts formula. Here is the by parts formula, uv minus integral v du. Write the question on the left side, which is integral x e minus 3x dx. Okay. Now uv, multiply these two for this. So we will get minus 1 upon 3 x e minus 3x. This is uv. Copy the integral. Now we need v du. So v du, multiply these two. So we will get minus 1 upon 3 e minus 3x dx. So copy this. This is the solved part, the integrated part. Now this is 1 upon 3 and integrate e power minus 3x. So e minus 3x divided by minus 3. Okay, get the simplified form of this result. Minus 1 upon 3x e minus 3x minus 1 upon 9 e minus 3x. Okay, now substitute this result into equation 1. This is equation 1. Write c as well. We write c on one side, on right side here. This is equation 1. Just copy this and substitute this result over here. So minus 1 upon 3. To save time, I'm just copying this. Okay, here we have y minus 5 ln 5 y plus 5. Now we need the value of c, and for that we have the given condition. It's given y0 x0 and we need equation in terms of x and y. I mean the equation in x and y. We don't need to make subject, neither x nor y. So y is 0, x is 0, therefore 0 minus 5 ln 5. This is 0 because of this x, but avoid careless mistake. Don't consider this 0 because e power 0 is 1. Anything power 0 is 1. So we have got c. It's shift this on right side, left side in fact. So 1 upon 9 minus 5 ln 5. This is c. Now substitute c into this equation. I'm copying this equation. See, a lot of algebra is required or involved. Alright, now shift this ln on left side, because whenever we have two or more ln's, we convert them into single ln by using product or quotient law. So plus 5 ln 5, copy this minus 5 ln y plus 5 minus 1 upon 3 x e minus 3x copied minus 1 upon 9 e minus 3x copied plus 1 upon 9 is also copied. So by using quotient law, we have taken 5 common first, ln y upon y plus 5. Sorry, 5 upon. Okay. Here we can take minus 1 upon 3 common. So we have x e minus 3x plus 1 upon 3 e minus 3x minus 1 upon 3. That's the exact answer. This is the equation of x and y. Please check this solution from here. be extra conscious to avoid careless mistakes. Now, substitution question. This question is relatively easy. Substitution. So, substitution is given x root 3 tan u. So, always differentiate given substitution to get dx. The differential of tan is sec square u. Now get dx. Therefore, dx is under root 3 sec square u du. Box this dx. Now get the limits. For limits, always use given substitution. Okay. So when x is 1 and when x is 3. Now substitute 1 here. So u is, under root 3 tan u is equal to 1. Therefore, u is 1 upon root 3, then tan inverse, so it should be pi by 6. Root 3 tan u is 3. Therefore, u is tan inverse 3 upon root 3, which is pi by 3. Now box these two limits as well. We need all these boxes for the substitution into given integral. Now copy this given integral. Okay, so I means integral. When x is 1, then u is pi by 6. When x is 3, u is pi by 3. So pi by 6, pi by 3. X cube. Now get x cube from here. Also x square as well. We need both x cube and x square. So get the both. So from this, we are getting x square, which is 3 tan square u, and x cube is 3 root 3 tan cube u. Okay. So x cube is 3 root 3 tan cube u. Right, in denominator x square is 3 tan square u and dx is root 3 sec square u. Make sure you substitute everything very carefully, also dx as well. Now get its simplified form. Pi by 6, pi by 3, now take 3 common from denominator, so we have 3 1 plus tan square x, tan square u, sorry. See, when we will multiply this root 3 with this, we will get 3, so 3 3 is 9, tan cube u sec square u du. Alright, so cancel these two, 3, You know, this is sec square u, the identity. So sec square u cancelled. I'm showing the working. I'm not doing this directly. Pi by 6, pi by 3, 3, 10 cube, u sec square u du. Okay. In denominator we have just sec square u. I use the identity. So finally we have 3 tan cube u, and this is what we had to show. See, 3 tan cube u. Now please check the solution. Part B, we have to integrate the integral. So it's pi by 6, pi by 3, 3 tan cube u. Now how to integrate this? You just need to split this power. This is also an important question. Many students don't know how to integrate tan cube. So bring 3 outside the integral. Tan cube, you can write this as tan u tan square u. Now apply the identity here. 1 plus tan square is sec square. So tan square is sec square minus 1. And then use basic formula 1. Tan u 1 minus sec square u. By the way, this is the way we integrate cos cube and sine cube as well. I am using the same concept here. 3 pi by 6, 3 and this pi by 3. Now multiply tan u with both. So tan u du. 3, distribute the integrals as well to make it simple. Tan u, I explained this, just hold on. Now see, I multiplied tan u with this and with this. So with this I got tan u, and with this I got tan u sec square u, and then I distributed integral. I gave the integral to both the functions. Now this is the structure of basic formula 1. Basic formula 1. Why? See, this is the function and its differential is here. Tan u, if you differentiate tan, you'll get sec square u. Whenever we have product of like functions, then always try to apply basic formula 1. That's the hint. Now integrate tan u. It's not easy to integrate tan u. To integrate tan u, write tan u as sin u upon cos u. Tan u power 1. Just copy this. We will integrate both simultaneously. Now, see, this is basic formula 2. What a question. Basic formula 2. This structure and this structure is basic formula 1. See, the differential of cos is negative sine. So sine is there, minus 1 is missing. Here in this differential, minus 1 is missing. So 3 according to basic formula to write ln cos u and divide ln cos u by the missing differential, which is -1. Pi by 6, pi by 3. The coming paper, the paper on 15th May will be a harder paper because this paper is very hard. Now integrate this. According to basic formula 1, see the differential is sec square u. The differential of tan is sec square. So according to basic formula 1, copy this. Add 1 in power. The power is 1, so 1 plus 1, 2. Divide this by the resultant power. That's it. Nothing was missing in the differential, so it's fine. Now apply the limits carefully. ln, when we will apply pi by 3, so cos pi by 3 is half, so ln half. Cos pi by 6 ln is under root 3 upon 2. This is minus 3 upon 2. Tan pi by 3 is under root 3 square. Tan pi by 6 is 1 upon root 3 square. Okay. Now copy this, solve. Whenever you go on to next page, move on to next page, copy this very carefully. So ln half and ln root 3 upon 2. So use quotient law here. So 1 upon 2 divided by root 3 upon 2. This is the quotient law of ln. Minus 3 upon 2 is copied. This is 3. This is minus 1 upon 3. Okay, I made a mistake. I'm so sorry. I wrote the wrong identity here. Let me correct this in a different color. Sec square u minus 1. I wrote this here correctly, but I wrongly wrote here. I wrote here wrongly. So sorry. So tan u sec square u is positive. This is positive. Alright, so this is negative. See, tan u minus 1, this is negative. Right, and this is positive. Positive, negative. So minus minus cancel, positive 3. This is already positive. Okay. Positive, positive. Thank God. Okay. So this is 3 this 2, then this 2 cancelled, ln 1 upon root 3. Okay, this is 3 upon 2, 8 upon 3. Now 1 upon root 3, you can write 3 power minus half. This is, I think, 4. So we are getting minus 3 upon 2 according to power law. We can bring minus half here, plus 4. Now give your answer in the required form. This is the required form, P plus Q ln R. Therefore, P is 4 and Q is minus 3 upon 2. Okay. Please check this solution again. Okay, next question. 2 questions are left. This paper has 11 questions. The next question is implicit function. This question is of implicit functions. Now, first copy the question. Now we have to find dy upon dx. So taking d upon dx on both sides. So I am taking d upon dx on both sides at this step while copying the question. Since this is the coefficient, so we can write this before d upon dx. Now this is u upon v, this. So the formula is v square v u prime u v prime. Okay, this is implicit, so when you differentiate this, you will get 2y dy upon dx. Now apply product rule here. So x upon 2 square, copy x plus 2. Now differentiate u. The differential of x minus 2 is 1. Then copy x minus 2 and differentiate v, which is 1. Now we have 2y dy upon dx k. Here we have 4. When we simplify this, x cancelled, and this is 4. Now check this result. We have to prove this. See, in this proof we don't have k, and here we have k. So we need to make k subject from this given. So make k subject. For k, copy the question, k times x minus 2 over x plus 2. Therefore k is y square x plus 2 x minus 2, right? I shifted this here. Now substitute k into this equation. Substitute k here. Here. Therefore we have 2y dy upon dx. Instead of k, we can write y square x plus 2 x minus 2, copy the leftover thing, 4 upon x plus 2 square. Now cancel this x plus 2 with this 1 power. Okay, and 1 power of y will be cancelled. So we have dy upon dx. It's y 4y square divided by 2y x minus 2 x plus 2. After cancellation we have this. Now finally we have 2y divided by x square minus 4, and I think this is what we had to show. Yes. Please check the solution. I'm taking 20 minute rule break. Part B of this question. Again an important question. Alhamdulillah. Given that case 5, find the angle between the tangents to the curve at x3. So case 5, x is 3, and what about y? We need y. So first copy the given equation. This is the given equation. We are working for y. Therefore, y square 5, 3 minus 2, 1. This is 5. So y square is 1. So y is plus minus 1. Make sure you must write plus minus 1. So we have 2 points, 3, 1 and 3 minus 1. That is why we have 2 tangents at x3. Now get the gradient. This is the gradient equation. Now substitute x and y both into this equation to get gradient. So y is 1 and x is 3. So 3, 9 square minus 4 is 5. So this is 2 upon 5. Y is 1, so 2 upon 5. This is minus 2 upon 5 because y is minus 1. So we have got 2 gradients. Remember we did this formula in P1, angle between 2 lines. Tan theta m1 minus m2 1 plus m1 m2, where m1 is greater than m2. You must have done this formula in P1. So this is the larger gradient and this is the smaller gradient. So m1 is 0.4 and m2 is minus 0.4. Okay. Now substitute these gradients into this formula. So 0.4 minus 0.4, 1 plus 0.4 minus 0.4. Okay. So in numerator we have 0.8, in denominator we have 1 minus 0.16, which is 0.84. So we can write this as 80 upon 84, which is 20 upon 21. So we have tan theta 20 upon 21, right? Now we need inverse of tan. Tan inverse 20 upon 21. Now compare this with the requirement. The requirement is this. This is the requirement. A. So A is 1, B is 20, whereas C is 21. That's it. Please check this solution. Finally, the last question. The last question is of vectors. I will make a lecture on vectors questions, inshallah, soon, inshallah, most probably on this weekend. Okay, the points A and B have position vectors this and this. Show that perpendicular distance from A to line OB is this. Okay, first get the equation of line O and B. Equation of the line OB. Let's suppose this is B, this is O, this is Q, the direction vector. So Q is OB and OB is 4, 2, 4. Now the equation of this line is, you can use either B or O. It's better whenever O is given on a line, always use O to make the equation simple. Lambda Q. Okay. So O means 0, 0, 0. Since origin is on the line, so I am using origin. 4, 2, 4. Therefore, the equation is lambda 4, 2, 4. For shortest distance, we must have equation of the line. Now, for shortest distance, make a rough sketch. If you are weak at this topic, then watch my lecture on shortest distance. It is in the live section of my YouTube channel. Now this is A. We need shortest distance from A to this line. Okay, this is O. This is a rough sketch. This is Q. It's 4, 2, 4, I guess. Yes. This is the foot of perpendicular from A to this line, X, Y, Z. Now the most important thing while solving this shortest distance, get F, OF vector. Since F is on this line, so replace R of the line by OF. Remember, we always replace this R by OF. So OF is R is 4 lambda, 2 lambda, 4 lambda. I replace this R by OF and multiplied lambda with this. This is the first step, the most important step. Get the foot of perpendicular by replacing R of the equation. Okay, now get AF. We have A, it's 2, 2 minus 1. Now get AF vector, it's OF minus OA. Alright, so OF, we just found it. It was 4 lambda, 2 lambda, 4 lambda, right? OA, it's 2, 2 minus 1. Now get the simplified form of this. 4 lambda minus 2, 2 lambda minus 2, 4 lambda plus 1. Alright, we have got AF. Now the problem is lambda. We don't have lambda. So for lambda, see, this vector AF is perpendicular to this vector Q. So for lambda, use this fact. AF is perpendicular to Q. Therefore, their dot product must be 0. If two vectors are perpendicular, then their dot product is 0. So AF is 4 lambda minus 2, 2 lambda minus 2, 4 lambda plus 1, Q. Q is 4 to 4. Right? Now do straight multiplication and put plus sign between the numbers. So 16 lambda minus 4, then put plus sign. 4 lambda minus 4, then 16 lambda plus 4 is equal to 0. When we will solve this, we will get lambda, which is 2 upon 9. Right? Now we need AF, the shortest distance. We need this distance. So we need AF vector. This is the AF vector. Substitute lambda here. Therefore AF 8 upon 9 minus 2, I'm writing directly minus 10 upon 9 minus 14 upon 9. Basically I'm substituting lambda 2 upon 9 and 17 upon 9. Now take its magnitude. So 100 upon 81, 196 upon 81, 289 upon 81. This will give you this result. 1 upon 3 under root 65. And this is what we had to show. Please check this solution again. Last part, finally. Alright, the point C is this, is given. OC is perpendicular to AB, so get AB first. It's OB minus OA. So OB is 4 to 4 and OA is 2 to minus 1. So AB vector is 205. Right. Now it says OC is perpendicular to AB. Now take the dot product. OC dot, first write OC perpendicular to AB. Therefore OC dot AB must be 0. Now OC. OC is 3PQ. Always use column vector form. It's easy to handle vectors. Now 6, 0, 5Q. Finally we have Q. It's minus 6 upon 5. We have got Q. Now angle AOC is equal to angle COB. It's given also angle AOC is equal to angle COB. Now, how to manage this? Read from the middle, OA dot OC. This is the way to read this. OA dot OC divided by their magnitude. This is the formula of angle, the scalar product. You can find this formula from MF 19. Now this is OC dot OB, like this. OC dot OB divided by OC OB magnitudes. Since these two are same, so cancel these two. Okay, so we have OA dot OC divided by magnitude of OA. Here OC dot OB divided by magnitude of OB. Now write vector OA. OA is 2 minus 1. OC is 3P and Q, we have Q minus 6 upon 5. 3P minus 6 upon 5. The magnitude of OA should be here. It's 9. The magnitude of this vector. All right. Now OC is 3P minus 6 upon 5 dot OB. It was 424. Now write the magnitude of OB here, 36. Now take dot product of these two. So 6 2P plus 6 upon 5 divided by 3. 12 2P 6 for the 24 upon 5 divided by 6. 3 1 the 3 2 the. Right? Okay, so 6. Now multiply this 2 with this. So 12 4P 12 upon 5 12 2P 24 upon 5. Simplify this and get the value of P. P is minus 18 upon 5 and Q is minus 6 upon 5. Alhamdulillah, finally we have done this. I hope this lecture is helpful for you, and if you find this helpful, then do share it with your friends. Please subscribe, like and share the link so your friends may benefit from it. All the best. Allah Hafiz. Sallallahu Alaihi Wasallam. Alhamdulillah Rabbil Alameen. Ameen. Allah Hafiz.